So good morning once again. For today, we're just going to discuss some issues, no? Issues in OLS, sa regression natin. So if you notice, I didn't give you any file kasi we'll be working from the ground up dun sa mga basic models lang tayo ngayon kasi maraming wala, no? And I just want to discuss some things that can easily be understood even just by viewing. Okay, so ano yung mga main topics natin? Ano yung mga issues na to? For one, we have problems in what we call scaling. Not problems, but how do you scale variables? Ano pa? Sometimes we might need to do standardization of variables, or expose or convert variables into logarithmic, no? Logarithmic, or sometimes baka mga quadratics, quadratics or polynomials, mga variables natin. And then we'll also look into interactions. Definitely guys, hindi natin matatapos lahat to ngayon, no? Maybe hanggang a bit of logarithmics and quadratics, but our topic will be quite simple. It will just allow us to have a working knowledge on how to scale data, how to standardize data, and some of the interpretation. Okay, so Control-Shift-M, oops, mali. Control-Alt-I, mag-create tayo ng panibagong data chunk. So mag-load muna tayo ng libraries natin. Library. Okay. Baka hindi nyo pa na-install guys yung ano. Okay, let's install first some packages. Let's install si EM means gagamitin natin mamaya. Tapos ano pa? Si VCD. Ano ba si VCD capital ba to? VCD, I'm not sure. No? VCD extra, tingnan muna natin. So maybe let's, of course, yung gagamitin natin ngayon, si Wooldridge. Okay. So maybe itong tatlong ano muna, packages. So kindly install that. And then if you're done, guys, i-load na natin i-library natin. You can see the screen, right?
Yes. Oh.
Okay. So kindly load those packages first. And then once you have done that, tama yung spelling ko ng VCD extra. Pinaka-importante sa lahat natin ngayon is library Wooldridge. Once you're done guys, paki-chat kung na-load nyo na si Wooldridge, EM means at saka si VCD extra. Pause share muna ako guys so that hindi waste ng time. Kindly chat na lang ha, please. Okay, so about the code a while ago, kailangan guys naka-combine yung mga yung mga packages. Yeah. When you try to run it, nag-error ba?
Sir, I think you're naka-pause share.
Pause share pa pala ako. Okay. So I was told, nag-chat si Nick sa akin, installation process only worked when we installed it one by one. When grouped, kasi hindi yata tayo naglagay ng combine, no? If we do this, pag naka-combine siya, okay, nag-error. Okay, error, yeah. Okay, so ano lang guys, pag hindi siya nag-run together, you can of course install it one at a time. Will be updated, currently loaded, restarting, strongly recommended. Sige, let me restart. Error saving plots direct to the system cannot find the path specified. So how about the rest guys? Nag-error ba kung sinabay-sabay nyo pag-install ng packages? If it doesn't work guys, pwedeng individual na lang. Oo nga. Sige. Sige, we'll wait guys kasi kailangan natin si Wooldridge. No? Ito yung gagamitin natin for this session. So, si EM means baka next meeting pa to. No? Pero at least we tried loading it. But what's important is i-load nyo na muna sa Wooldridge. Tsaka siguro si VCD Extra, simple lang naman yan. Yeah, oo. Thank you, Richmond. Kailangan C, no? Kanina I forgot to put the C, kaya nga nag-error siya. Thank you, Richmond. Yeah. Richmond, paki-share naman yung ano mo, yung message to everyone. Ziska, na-load mo na?
Not yet po.
Not yet. Sige. Ano rin na-load mo? Combine ba o one at a time?
I tried po sir, one by one na lang.
Sige. Ang importante mo na ma-load si Wooldridge. Thank you, Richmond. Pati siguro si DCD Extra. Simple lang naman si DCD Extra. Okay, so while the rest of you are still loading it, yung mga naka-load na, guys, always check first. Siguro check muna natin si Wooldridge. No? What does this package contain? Oops, mali. Mali yung spelling ko. Wooldridge. So package. Info muna tayo para aware tayo, guys. It's always good practice to check yung mga functionalities available for a particular package. Okay. Ngayon minsan ayaw siya dito. So, pwede natin dito lang hanapin. Dito sa packages rule. Yan. Alright. Click ko to. Alright. So si Wooldridge, guys, it contains 111 data sets. No? This is from yung author, si Jeffrey Wooldridge. He wrote a book on introductory econometrics. And ito, may mga data set na kasama. Okay? It's mostly data set. Wala yatang functionalities dito. So there are 111 data sets in this package. Description file, let's see. There. So students learning both econometrics and R may find the introduction. However, if the text is introductory, then okay siya. So it provides us with data. Okay. Tapos, ano ba yung sinabi niya dito? User guide and vignettes. Okay, so may mga examples dito, no? Here, so may mga examples dito. Very good resource, very good reference. Okay, so I will leave you guys with trying to study what are the contents of this. So econometrics tong topic na to. So maraming ano dito, you'll learn a lot from this package. All right, so yung isa naman, ano ba si BCD? Tingnan natin, no? Packages. Anong gamit ni BCD Extra? There. BCD Extra. Okay, ang simula niyan BCD. So, description ng file na to. So, hindi niya in-explain dito kung ano yung... So, actually, this is the extension of the VCD package. Ang tingnan natin, guys, yung VCD package. So, visualizing categorical data. So, that's what VCD means. Visualizing categorical data. So, magandang gamit ito for data visualization, in particular for categorical data. Although may numerical din dito, no? So marami siyang functionalities. Okay, and then yung VCD Extra is just an extension of this. Visualizing categorical data, and may mga code demos din siya, no? User guide, package vignettes, other documentation. Okay. There are examples here, guys, that you can study or you can use. Okay, so yung EM means baka hindi natin abutin ngayon, pero tinan na rin natin, guys, yung ano. Tinan na rin natin itong EM means. Yan. Estimated marginal means, aka least squares means. Okay, it's used for prediction, sa interaction natin gagamitin to. So dito sa last topic na to, no? So but hindi naman natin aabutin tong sa interaction. So at least naka-ano na sa inyo, naka-load na. Description file, and then ito yung mga functionalities niya, marami ding functionalities to, no? Yan, EM means. Kukunin yung mga marginal means, EM list, EMIP, interaction style. Okay? So ito yung gagamitin natin pag ipa-plot natin yung interaction plot ng estimated marginal means. Okay? So first, guys, let's first see ano ba yung mga marami kasing di ba? Gagamitin natin yung BCD Extra na package to determine ano ba yung mga data set. Let's use the data sets, and then we'll bridge. Dito lagay lang natin dito data sets available in package voltage. Notice, guys, as I said, hindi ako nagbigay ng no, kasi gusto kong kayo ang it will help when you are the ones who are coding itself. Na-notice ko kasi pag binibigay ko lang, yung learning, yung mastery becomes diminished. Pero pag kayo mismo magsusulat, mas maganda. So let's see guys kung ano yung laman nitong package na to. So let's see yan. So this package gives us what the content of let me run it. So Wooldridge, no? So 111 all in all, 100 data sets. In fact, sa take-home exam nyo, pwede kayong kumuha dito. No? You can use this. And then, andito yung dimension niya, data frame, and then title. And you can use also this one to see yung ano yung laman ng data na yun. No? So let's see, gagamitin natin ito ngayon, itong birth weight. So let's, this is the first date object that we're going to use in data frame na birth weight. So 1388, 1,300 observations by 14 variables. Let's run this. Ayaw. Natin isang ano lang. Yan. Minsan ayaw ng dalawa kasi yung dalawa minsan pang package mismo. Okay, so this is some information about the data, the object birth weight. So this is from Wooldridge, as you mentioned a while ago. And it was used in a study, instrumental variable estimation of count data models, application to models of cigarette smoking behavior. Okay, so ginamit sa review of economics and statistics by Professor Mulahay. And then ito yung laman niya, no? Yung data birth weight. 14 variables siya. Okay. Family income, cigarette tax, etc. So in this discussion, we would like to see yung birth weight, which is in ounces, how the birth weight, okay, of an infant is affected by yung family income ng of course ng parents, no? Sa state na yon, kung may cigarette tax ba, etc. And then we have here some categorical variables, no? Yung white, male, mother education, years done. Okay, so we're going to use that now in order to look at our first lesson, yung scaling. Okay, madali lang naman yung scaling. Okay, so let me write here scaling muna tayo. Ano ba ibig sabihin ng scaling, guys? Scaling just refers to converting your data from one dimension to another. Kunyari, yung data natin in feet, tapos gusto natin in inches, or in pounds, tapos gusto natin in ounces, or vice versa. So there may be some reasons why we'd like to use instead yung data na nakuha natin is in particular dimension or magnitude. Tapos gusto natin na baguhin yung yung dimension niya in a particular measure. Okay, so let's do that here. Dito yung birth weight natin, tingnan natin birth weight. Ang sabi dito, ang birth weight is in ounces. Okay, so for our first topic here, pag mag-scaling tayo, kunyari gusto natin gawing pounds na lang yung birth weight. So how do we do that? So let's do this. Convert ounces into pounds for birth weight. Okay, madali lang to, guys, no? There are several ways to do this. You can na-access na ba natin si Di pa natin na-access si data, birth weight, and then view birth weight. Ano ba yung scaling? Converting variables. Converting variables from one dimension or from one magnitude or dimension to another. Okay, yun lang ibig sabihin ng scaling, guys. And this is one of the easiest in sa further issues natin ng ordinary least squares. No? Okay, so let's na-access ba natin data? Okay, let me just close this. Okay, data, and then view natin si birth weight. Birth weight not found. Bakit? Naload ko na ba si ano? Library Woldridge. Okay, data. Yan. Hindi ka pa na-load si ano, hindi pa nag-run yung pag-load ko ng Woldridge. So view. Okay, so this is our birth weight data set. Let me pause for a while. Kindly chat please kung na-access nyo na yung, ano, yung birth weight data set natin. Okay, thank you. All right. So there are several ways, guys, to convert this. This is in ounces. Let's suppose that in our study, ang gusto natin na yung birth weight natin in pounds. So the conversion factor is that 1 pound is equal to 16 ounces. So that's very easy, guys. Yung scaling, madali lang sa Aryan. So ano yung pwede natin gawin? Ito. Okay. We can, so we'll create this. Scale ounce to pounds direct. Okay, I'm giving it a name para mas madali natin data. Again, guys, this is a good practice. Lalagyan natin ng name yung ano natin, yung R chunk para madaling data sets. So that it's easier to navigate through it. Install packages. Okay. All right. So when I go to a particular code chunk, ito, yan, kikita natin, yung mga chunk natin may mga pangalan. So it's very easy to go to that code chunk, especially, guys, if your model has become very big, ilang rows na, thousands na, tapos baka mahirapan kang hanapin yung a particular chunk. So indexing it is very good. So let's create now another object. Gawin natin birth weight, gawin natin in pounds. Birth weight underscore pounds. Control minus. And then how do we do this, guys? How do we change this? It will simply be your birth weight, diba? Birth weight okay, so the data set is birth weight din. Nakakalito kasi ang pangalang birth weight. Palitan natin, guys, yung pangalan ng birth weight kasi may variable din tayo ng birth weight. So let's call this data. Let's call birth weight. Let's call it data na lang. That one. Wait. Mali. Sorry. Sorry, guys. That one and then birth weight. All right. So I'm going to create an object called dot one, and it's the same as birth weight. Okay, so here, may dot one na tayo dito, no? And it's the same as birth weight. Okay, I'm using a different name kasi may variable tayo na birth weight din eh. So malilito lang tayo niyan. Okay, so here, we're creating an object called birth weight in pounds. And it's actually from your dot one, then that one natin, tapos ano guys? Sorry. Why don't we put that, i-insert na lang natin, no? Sige. So that one, ganito na lang. So this is one way. That one, let's create this object birth weight in pounds. Okay, so what am I doing now? From my that one object, I'm going to insert this variable, birth weight, and it's equal to, ano siya, no? It will be that one birth weight and divided by 16. Okay, ganun lang guys, no? Okay, so what did we do here? That one and then dollar birth weight in pounds. Ibig sabihin nito, I'm creating a variable in that one, and then it's equal to yung that one na data natin, specifically yung birth weight, divided by 16. So this is to convert ounces to pounds. So we're creating a new variable here, guys, about birth weight in pounds. Okay, so let's run this. And let's now look at that one natin. So tingnan natin itong that one. Notice guys, yung that one natin, kanina 14 variables lang yan, di ba? So nadagdagan na ng isa. And let's view this. So if we can see at the end, meron tayong birth weight underscore pounds. So kinonvert na natin yung birth weight from 109 to 6.8125. So meron tayong pounds ng birth weight. Okay, clear so far, guys? Clear so far? Okay, good. So we can now regress, guys. You can now regress our birth weight in pounds to whatever variable we want to use as predictors for birth weight. So as I said a while ago, in this exercise, we would want to predict yung birth weight ng bata. Okay, using yung pounds, making use of whatever factors na gagamitin natin as predictors. Okay, so we'll make it simple. Ang objective lang naman natin dito is more of manipulating the data so that we're able to scale it. No? Okay, so sige, let's Control Alt minus. Oops. Nalilito ako minsan sa pag-insert ng code chunk or ano. So Control Alt I. So I'm inserting a code chunk. So let's create now a model. Magre-regress tayo. Model 1. Lagyan natin to LM linear model using birth weight in pounds. Okay. So we're going to regress birth weight. Okay. We're creating an object called model 1. Tapos paano tayo mag-regress, di ba? I hope you haven't forgotten birth weight. Okay. So paano yun, guys? Birth weight. Remember guys, in ounces to, di ba? Pwede ba yun na i-divide natin ng 16? Okay? So ang dependent variable natin guys, birth weight divided by 16 in order to convert it into pounds. Okay, and then you know, yung tilde natin, di ba? For regression, tilde is equal to, ano gagamitin natin dito? Siguro chosen muna yung mga, let's say, yung SIGs, no? Yung SIGs gamitin natin as a predictor. And then plus, let's just limit it. And family income siguro. No? So let's just use data is equal to that one. Okay. So let's just use family income. Two variables. So just to illustrate, guys, again, ang objective natin dito is not really so much on the regression, but rather on scaling. Scale natin. So a birth weight divided by 16 regressed on SIGs plus family income, data is equal to that. And then summary natin, summary mod 1. Okay, so let's run this. All right, so we have this, guys. We have this regression output. Our intercept, our predictor cigarettes, and our family income are all significant predictors of birth weight. Okay, anong interpretation ito? Ang SIGs ba dito? SIGs is SIGs. So ito yung sticks, no? Smoke per day while pregnant. So ito in-interview nila yung yung mga mothers. So ilan daw yung cigarette na ano na ni-smoke niya during pregnancy. So ang lumalabas dito, SIGs is negatively correlated with birth weight. Ibig sabihin, for every 1 unit increase in cigarette smoke per day, birth weight was reduced by 0.0289 or approximately 0.03 pounds. Birth weight was decreased by 0.03 pounds. Okay, pounds na yung interpretation natin, guys, kasi kinonvert na natin tong birth weight divided by 16. So pounds na yan. And then on the other hand, family income. Ano naman yung relationship ng family income? Family in thousands, no? So for every 1,000 increase in family income, birth weight increased by around 0.0058 pounds. So there was a positive relationship between family income and birth weight, ceteris paribus, no? All things being equal. All right, pause muna ako, guys. Questions? Questions? Clear so far tong ano? Yung pag-scale natin. So pwede palang diretso, no? Pwedeng i-diretso natin dun sa dependent variable natin, yung pag-divide. Let's compare this. Tingnan natin, guys, kung pareho lang siya, just to be sure, no? Okay. So I'm going to create mod 1. Okay, mod 1 A na lang. Mod 1A, alt minus LM. So birth weight natin. Let's use the yung naka-pounds na, no? Birth weight in pounds. Shift tilde and then SIGs. SIGs plus family income. Fam Inc. Okay. Data is equal to that one. And then summary. Mod 1A. All right. Let's see, guys, if we get the same answer. Ito ang ginamit natin na predictor, yung birth weight in pounds already. Kasi baka hindi naman niya dinivide, eh, no? Ito yung birth weight in ounces, then dinivide natin ng 6. So what if we use directly yung birth weight in pounds na data, and then let's see what will be the summary. Okay, are they the same? Yes, exactly the same values as yung diniretso na natin na birth weight divided by 16. Okay, exactly the same. Okay, questions so far, guys? Clear ba? Okay, Jiska, thank you. About the rest? Questions kayo, Michelle, Nick, Rhea, Richmond? Clear naman so far. I hope it's clear. So again, just to recapitulate, ang topic natin, scaling. Okay, ano yung scaling? Binabago natin yung values yung dimensional values ng mga variables natin. And there are several ways to do it. You can first create a variable, that's the converted one. Or you can, if you're going to use regression, you can straightforward convert yung variable natin. Okay? Pareho lang siya ng result using the converted variable or converting it into the LM function itself. All right. So this time, guys, let's create another model, mod 2. Mod 2 LM. Wait, sandali ha. Convert muna natin, guys, convert si SIGs per stick yan, di ba? 2 SIGs per pack. Okay, per pack. I'm not a smoker, guys, pero alam ko sa isang pack, 20 cigarettes. No? So what we're going to do is, this time we're going to convert SIGs into, which is per stick, into per pack. So again, that one, and then dollar sign natin, SIGs, gawin natin per pack. Out minus. All right? So that's same thing as we did a while ago, guys. Ito, no? Mag-divide tayo. That $1 SIGs, and then divided by guys, divided by 20. Okay, I'm assuming, guys, na na there are 20 cigarettes, 20 sticks per pack. Okay, so let's run this. Okay, error. Bakit nag-error siya?
Sir, yung spelling po nung 6.
Ay, oo, sorry. Pala yung spelling. So, kita nyo, very sensitive si R sa sa mga spelling. Okay, thank you. All right, so let's take a look at that one. Meron na tayong panibagong variable, no? So it's now SIGs underscore pack. Okay, so ang liliit lang naman kasi ng SIGs, no? So hindi umaabot yung no? Tingnan natin, guys, kung i-round natin to round, let's say 5 decimal places. Tingnan natin, ha? So run ulit natin. Okay, then let's see that one. Hindi siya dito, no? Hindi siya nagre-reflect dito. View. Okay. So kasi ang ano ba to? 6, 0 pala to no? Yung iba 0 kaya 0 talaga. If I go below, okay, ano na lang, summary, para mas makita natin. Summary si that one. Let's see kung ano yung summary ng SIGs natin ngayon. SIGs per pack. Ayun, ang average niya, ang minimum 0, maximum may naka 2.5. Okay, so hindi, ano talaga. Kaya nag-0 pala siya kasi may mga SIGs na may mga hindi gumagamit talaga. Ang maximum may nakaka 50 sticks per day. So that's why doon ang galing yung 2.5 packs per day. All right. So sige. So bali wala pala tong round na to, no? So let me delete this. Wala siyang gamit kasi may mga whole number naman. Okay, ano na to? May iPad dito. Okay, so I'll just revert to the original na, no? Okay, now let's once again, let's now create a model. Let's call it model 2. Alt minus, and then LM ulit natin. Okay, LM natin si birth weight. Okay, so divide natin ng 16, gamitin natin isa kanina. Alt minus, shift tilde. Then, ang gagamitin natin guys is 6. Then, subukan natin divide by 20. And then plus family income. Data is equal to that one. Okay. Let's see guys, kung ano mangyayari. Si birth weight, dinivide natin ng 16. Si 6, dinivide natin ng 20. Okay? So, this time, we are regressing yung per pound na birth weight kay 6 na per pack. What happens guys if you run? Paki-comment nga. Did it run or not? Okay, error in formula. Thank you, Richmond. Yeah, error. Error for Rhea din. For Ziska, error din. Okay, thank you. Good. Error din kay Richmond. Okay. So tama kayo guys, no? Magkaka-error talaga. Pero bakit Bakit kanina pwede naman? 'Di ba? Ito, dinivide natin ng 16 to. Tapos ba't dito pag dinivide natin yung 20? Now, okay. So lagay ko dito. Why did this not work? I mean yung 6 divided by 20. Kasi guys, alam natin yung birth weight divided by 16, mag-work yan di ba? Right? Mag-work siya, nag-work siya kanina Now, bakit itong 6 divided by 20, it does not work? Okay, very strict guys you are sa LM function. Na kapag if we're doing scaling, we cannot just divide or multiply a particular variable with a particular number. Okay, gagamit tayo ng isang function. Okay. So I'll use this. Control C, Control V. Okay. I'm going to introduce this in order to insert a scaling, actually interaction to. Ginagamit natin itong I for interaction. We have to use the word I, letter I. Now, sa dependent variable, okay lang na hindi natin gamitin to. We were able to show a while ago that by using, okay, sige, tanggalin ko muna to Tanggalin ko muna yung I dyan. Pero dito guys, sa mga independent variable, kailangan lagyan natin ng I. So this is actually for interaction, pero ginagamit din to for scaling, I na to. So let's see, guys. Dapat dalawa. Then i-summary natin. Summary si mod 2. Mod 2. Okay, let's run this. Okay, now it worked, Now it worked. Okay, so by using that I letter, when we're scaling or interacting, like later on, hindi natin naabutan interaction sa Monday na yun. So this is how, guys, you modify your variable. So let's go back here, guys. Paano kung pwede ba natin gamitin dito yan sa dependent variable natin? Yes. Okay, so here I'm using I, and then i-regress natin. Wait, mali, Sorry. I birth weight divided by 16. Dapat ito. Dapat dito sa isa kanina. Dito. So since dito ako nag-modify, dito ako nag-scale. All right, yan. Will this work, guys, if we're using I for your dependent variable? Yes, guys. So whether without the I or with the I, it will work, guys, pag nag-scale tayo sa dependent variable, but not in the independent variable. So let me run this. Okay, it worked. Same output, same result, guys. Okay, so whether with the I in the dependent variable, walang problema. Pero sa ano guys, sa independent variable, hindi na pa pwedeng walang I when we're scaling. Yan. As you can see here, okay, may slight changes sa result. Tignan natin yung kanina, yung ang ginamit lang natin yung SIGs lang. Okay. Ito negative 0.028, no? Ito naman negative 0.57 kasi per pack na ginagamit natin dito, no? So what does this mean? So for every 1 pack increase in smoking, okay, the average birth weight will decrease by 0.578 pounds, no? Kasi naka-pounds to. Pounds, ceteris paribus, family income remaining the same. Okay, so when you're doing scaling, guys, ang gagamitin natin yung I. All right, clear yun, guys? Any questions? But of course, guys, you can use a variable that has been transformed, no? Pwede rin yun. Pero kung ayaw nyo nang gawin nyo, ayaw nang baguhin yung data nyo, tapos magdi-divide lang naman kayo, and you still want to maintain the original data, then gamitin natin interaction na by scaling our data using I. In particular, dun sa independent variable. Okay, pause muna ako. Are there any questions? Kindly chat, please, kung clear so far. Okay, good. Good, thank you. All right, so that takes care of scaling, guys. Madali lang scaling. Basta binabago natin yung dimension. Just make sure that when you scale, ang scaling natin pwedeng diretso sa dependent variable, pero dun sa after the tilde sign, yung mga independent variables, kailangan gagamit na tayo ng I. All right, next, guys, yung standard. Tignan natin yung standard variables, no? Standardization. Okay, so pag sinabi natin standardization, actually, it's called data coefficients. Okay, I'll explain in a while. So what do we do when we standardize? From your elementary stat, alam natin, guys, na pag nagsa-standardize tayo, what we do is to standardize a variable, we subtract the mean and then divide it by the standard deviation. Diba? Yun ang converting to normalized or normally standardized values. No? Basta standardized. No? You divide it by the mean, you subtract by the mean, and then divide by the standard deviation. Okay? So that's what we do when we standardize. Okay? So anong gamit nito? Anong gamit ng yan sa regression? Sometimes, guys, yung mga variables natin, mahirap i-interpret yung usual nila. And it's easier, and sometimes it's more helpful, may mga cases na ganun, na yung variables mas maganda kung standardized siya. Kasi pag in-interpret natin yan, we're not interpreting it based on the actual dimensions of the variable, but rather in standard deviations. So tingnan natin to example na to, no? Okay? Let's use, guys, the gamitin natin na yung H price 2 na data set. Okay, let's access the H price 2. This is also from Woolridge. Data H, H price 2. So, ano yung H price 2? You can see there, guys. H price 2. Okay, so i-view natin H price 2. Dito na siya, no? H price 2, 506 observations. So, what you have here is the price of the property. 506 properties studied. Tinignan yung prices niya. And then yung crime rate sa region na yun. Maybe, let's take a look at this para may ano tayo, may idea. H price 2, so that we have an idea what this data set is all about. Tapos yung, kasi sa ano guys, sa view, hindi naman natin makikita yung ibig sabihin ng ano, no? Makikita natin yung variables, but not the meaning of the variables. So price, this is median housing price. Okay, mga median housing prices. So crimes per capita crime to, no? Crimes per capita. And then NOx, this is nitrogen oxide. So this is nitrogen concern parts per 100 million. So this is parts per 100 million ppm. Okay, so this is the presence of nitrogen oxide sa air. So poison yun, no? Okay, then we have the rooms, average number of rooms, then distance, weighted distance to 5 employment centers. So, ibig sabihin, yung mga matataas yung figure, kunyari itong 6.59, ano ba siya? Average distance, weighted distance. Okay, pero hindi sinabi kung miles ba to o kilometers, no? Basta yung distance yan, average distance from the house to the employee centers. Radial property tax. Okay, property tax gives us the tax on property per 100, per 1,000. ST ratio, student teacher ratio, dun sa area na yon, no? And then, what's low stat? Perception of people lower status. Okay. Percentage of people pala, sorry. Lower status. So kung mataas yung lower status, ibig sabihin, katulad nito dito, 29.93%, ibig sabihin nun guys, itong area na to, itong room na to, itong house na to, okay, 16,500 na lang, maybe because of the low stat, no? Okay, we don't know. We will have to investigate. And then the rest are just log, no? Nakalog lang siya. Okay, so what we're going to do now, guys, is we're going to use yung concept ng standardization. Okay, first, let's regress first. Mag-regress tayo, tawagin natin model, ano na ngayon? Model 3, no? Model 3. Okay, model 3 natin, gamitin natin yung LM ulit. LM, so gamitin natin si price. Regressed on, sige, kunin natin yung NOx, yung poison, plus, syempre, isama natin si crime rate. Kung nakaka-affect ba si crime rate. Tapos, let's see, isama siguro natin yung rooms, no? Plus rooms, kung ilang rooms yung bahay. And then plus, tignan natin, distance siguro, distance. Okay, sige, yan na muna, no? Yan na muna. Yung price, yung crime, yung NOx, yung crime, yung NOx, yung rooms, yung distance. Okay, so those 4 variables and then data is equal to, okay, we named it H price, no? Okay lang, sige. Hindi naman, wala naman siyang kaparehong pangalan ng variable, H price 2. All right, so let's run this. Hindi natin nasama yung summary mod 3. Okay. All right. So let's see. Hindi. Akala ko walang significant. Okay, let me run this again. Summary mode 3. Yan. Okay, all are significant. No? Significant at 0.001. So, except for the intercept. Okay, we know how to create this equation, guys. So, anong ibig sabihin nitong mga parameters na to? Okay. First, itong NOx kunyari, no? Ano ibig sabihin nito? One unit, 1 parts per million increase in nitrogen oxide will reduce the price by $2,381. Okay? Diba? So sabi diyan, 1 parts per million na NOx will reduce the price of the house by 2,381. Let's assume these are in dollars. Isang ba to? Sa US naman to, so dollars to. No? Okay, ganoon din yung crime, guys. Ano ba tong crime? Per capita. No? 1 unit increase in crime per capita will reduce the price by 213.53. Okay, si rooms naman, guys. 1 unit increase in rooms will increase the price by $7,843. Ceteris paribus nga pala. Sorry, guys. I forgot to mention ceteris paribus for the others. No? And then for distance, 1 unit increase in weighted distance, whether it's in kilometers or in miles, will reduce the price by $786.92, ceteris paribus. So logically looks okay. No? Pag tumataas yung crime, bababa yung bababa yung price. Ganun din yung presence ng nitrogen oxide. Okay. Now, if you take a look at this, guys, we can see here that mahirap i-compare kung sino ba talaga yung may mas mataas na na effect dun sa price. Kasi magkakaibang dimension sila, di ba? Si NOx, siya? In nitrogen oxide, parts per million. Si naman, crime per capita na crime units. No? Si room naman, 1 room. So although in absolute value, mas mataas si rooms, no? $7,843. Ito naman si NOx, $2,381. Pero it's really difficult to compare them kasi magkakaiba silang dimension. Parang we cannot compare apples and oranges. No? Kasi, again, guys, isang unit na increase ni NOx, which is your nitrogen oxide ppm, it reduces price by 2,381. Pero si rooms, isang increase ng room. So, hindi siya comparable, guys. Hindi comparable si NOx at saka si rooms. Di ba? All right. So, let's now standardize this. Kasi pag standardize, guys, pag ini-interpret natin yan, it's no longer interpreted in terms of the units of the variable. But now, it will be interpreted in terms of scales. Di ba? In terms of scales. So, medyo mahirap yun, no? Medyo mahirap yun. Sorry, hindi mahirap yun. I was thinking ahead, no? So, we can now compare, guys. Who among the variables have really the highest effect on on price? Kasi everything now in terms of standard deviation. So, sa isang standard deviation increase in NOx, ilan yung effect sa price? So, isang standard deviation increase ni crime, ilan yung effect sa price. So it now becomes standardized, the interpretation natin, everything by 1 standard deviation, by one standard deviation increase. So comparable na yung mga estimates, no? So we can now say kung sino, guys, sino yung pinaka mas malaking impact dun sa price. Kasi pare-pareho na silang 1 standard deviation. Okay, so how do we do this? So dapat i-convert muna natin si si crime, si NOx, si room, si distance, into standard deviation, pati si price. So kung sabay-sabay yan, okay, subukan nga natin guys. Sige nga, i-convert natin guys. How do we convert now? Let's say price into standard deviation. Paano kaya? Tingnan natin guys kung, kasi kung long cut, no? Let's say long cut siya. So that one, then dollar. Sabihin natin price. Sabihin natin lang S price. So this is standardized price, no? Alt minus. So how do we do that, guys? Paano natin gagawin yun? Any idea? Kasi ang gagawin natin, so yung yung price, and then ima-minus natin yung average niya, diba? Divided by the standard deviation. Right? So, ganito ba yun? That one, yung price, diba? Minus, paano natin gagawin? Mean, ayan, mean ng that one price. And then, yung long cut to, no? Divided by standard deviation, paano? SD ng that one price. Tama na ba to? Price, tama. All right, so what are we doing here? We're creating this variable that the standard price, which is equal to the price minus the average price divided by the standard deviation. Let's see what happens, guys. Okay, ano sabi? Error. Okay, what's wrong here? Anong mali dito, guys? Did we miss out on something? Minamanual natin, ano? Buti lang talaga, guys, pwedeng hindi i-manualize. But we're just experimenting. So, anong mali dito? Diba, nag-create dito sa that one. Okay? So, S price ang create natin, which is yung that one price minus the average of your that one price, close natin, and then divided by the standard deviation. Tama ba yung function natin ng standard deviation? Yan, standard deviation, SD. Okay, what seems to be the matter here, guys? Anyone?
Sir, that one po ba dapat or H2?
Actually, sinadya ko yan. Tama, tama. So mali yung that one, guys. Wala na tayo sa that one. Ha? Walang price sa ano. Walang price sa ano. Very good, very good. I was actually testing you kung andyan pa kayo, no? So hindi that one, ha. H price yung ano natin, yung yung object natin. Okay, thank you. Ziska, ikaw ba yun?
Yes po.
Thank you, Ziska. You're correct. No? So hindi that one, guys. H price 2 na tayo. Yan. Okay, so run natin to. Okay, so let's see, guys, yung H price natin. Ayan, meron tayong standard. Okay, Meron tayong standard. Let's check. Let's check muna. No? Ano ba yung average ng ano natin? H price. What's the average of what's the average price? Yan. So 22,511 ang average. What's the standard deviation? H price 2. And then price. Okay, the standard deviation is 9208. Okay, let's see if this is correct. So for this observation, Control C, Control V. So that's 24 minus, okay, pwede kong i-copy to, ito na lang. Control C, Control V. Okay, and then divided by this one. Control Enter, and I'm having 0.1616. Okay? Ay, tama, no? Tama. Kaso, ibig sabihin, gagawin natin yan for every one of them. So I'm just showing you how to manually create your standard okay, but walang ano. Normalize. Okay, tingnan natin to. Density distribution function, quantile function. Hindi ito. Okay. So, there has to be a better way, guys. No? There has to be a better way to convert yung ano natin, yung data natin kaysa yung magpo-formula tayo. And imagine, guys, we're not only converting one variable, we're converting into several, we're standardizing several variables. So let me see, may scale function ba? Ano itong scale function? Okay, so the scale function centers or scales columns of a numeric ano, no? So ano yung default? Anong default niya? Okay, let's see. The value of center determines how column centering is performed. Okay. The value of scale, root mean square. Okay. So what's this, guys? Root mean square siya. Okay. So yung scale function, guys, it's a parang it's a what's the term for that? It's a, well, ang ginamit na dito generic, ano? So it's a function that you can use in order to scale and center matrix-like objects. So gagamitin natin siya. Tingnan nga natin what happens if I use this scale and then that one and then price. Tingnan nga natin, guys. Oops, that one naman ako. So this is H price 2. So let's create this object. X1 na lang. Okay, nag-create ako ng object na X1. And then I'm asking R to scale CH price 2, specifically the price. So let's see X1. Asa na si X1 here? All right. Ano siya, guys? 0.16, 0.16, negative 0.09. Tingnan natin dito sa H price natin. Okay. So, exactly the same, guys. Diba? So, instead of having to use the formula, which correct naman siya, guys, no? Kasi by definition, diba, ang standardized is subtract the mean and then divide by the standard deviation. But there's a function in R that we can use. Okay, so let's do that now. Okay, so gamitin natin guys, let's now create this object. Mod ano na ba tayo? Okay, preserve natin si mod 3. Let's call it mod 3A. At minus. Okay, so let's now regress LM. Now, since this is a direct function, guys, we're not going to use this. Kung gagamitin natin yung formula natin kanina, ito, if we're going to use this, ito, guys, ito, yung formula na to, then dapat ipapasok natin siya sa I, no? For the independent variables. But since we're not going to use this, we don't need the I, we can just use the scale of the price. Bakit siya naman dito? So LM natin, scale the price. No? So this way guys, the variable will already be converted. I-convert na siya into standardized value. So scale din ni Knox. Copy na lang natin to. Let me copy the regression above. Ito. Si crime. Yan. Control C. Control V. Okay, then let's put scale. Scale din si crime. Okay, then scale din si rooms. And then scale din si distance. All right. So ito guys, no? Very easy, very convenient. We are using the scale function. And then what will be generated? An LM function, a regression model, mod 3A. Okay, summary natin. Summary, mod 3A. Okay, summary ng mod 3A. We're using linear model. Scale natin si price, and then regress on the Knox, and then the crime, and then the rooms, the distance, using the data H price. And then let's generate this result. Let's run this. Okay, saan ako nagkamali? Mod 3A. Okay, paki-check nga guys kung saan ako nagkamali. Unexpected. Saan yun? Data is equal to ito, no? Open, close. Okay, nadalawa ko guys, sorry. Yan, run. Okay. All right. Now take a look guys at the at the result. What do you notice guys? What do you notice? So lahat to guys, lahat ng output natin are now in standard. These are now called, itong mga estimate na to, ang tawag talaga dito, beta coefficients. No? Mga coefficients to, pero ang tawag sa kanya, beta. Unfortunately kasi minsan pag binomodel natin, ang tawag din dun sa variable beta, kaya nakakalito. No? Pero strictly speaking, these are your beta coefficients. And your beta coefficients are actually your standard deviations. No? So anong ibig sabihin itong scale na to? Ito. Ang ibig sabihin nito guys, for every one standard deviation increase in your Knox, there's a corresponding ano to? -1. So 0.29 standard deviations decrease in the price of your room or of the house. No? Ganun din si crime. So everything now is expressed in terms of standard deviations. So now we can say that si rooms ngayon ang pinakamalaking impact kay kay price. Bakit? Kasi siya yung pinakamalaking beta coefficient. No? Anong ibig sabihin nito? For every 1 standard deviation increase in room, there's a corresponding 0.5985 standard deviations increase in your price, ceteris paribus. So pinakamalaki, kanina guys, di ba nag-regress tayo, lumalabas dito na pinakamalaki si rooms. But we cannot be definite, no? Na siya yung pinakamalaking impact sa price kasi magkakaiba yung nito, magkakaiba yung units niya. Dito ngayon, yung dimensions sila pare-pareho na. So these are now all in standard deviations. So we can now say that ang pinakamalaking impact sa price will be yung rooms. Okay? All right, is that clear guys? Clear ba siya kung ano yung difference ng yung unstandardized na generate natin kanina? Yung unstandardized guys, when we interpret that, it's all with respect to the unit of the variable. Per 1 unit of room, per capita of crime, per ppm of nitrogen oxide, per weighted distance per kilometer or miles of distance. Ganun ang pag-interpret natin. And we cannot say that si rooms ang pinakamalaki kasi nga unstandardized yung mga yon. Now when we use the scale function, naging sorry, ito pa rin unstandardized, no? Ito ngayon standardized. So everything is expressed in terms of in terms of standard deviation. And we can say that rooms has the biggest impact on the price. Kasi ang absolute figure niya 5.98 greater than the others. No? Okay, one last thing guys. Tingnan niyo si intercept. You notice that the value of the intercept is very, very, very small. 0.000, 15 zeros, and then 139. Okay, so hindi din siya significant. But anyway, hindi naman importante sa atin kung significant si intercept. Kasi whether it's significant or not, sa modeling, sinasama pa rin natin siya. However, the value is practically zero. No? Ganun kasi guys, pag ini-standardize, yung intercept, yung constant na to, it's forced to become zero. That's why, yung iba ang ginagawa, okay, let's copy this. Oops. Let's copy this, Control C. Okay, Control V. So, what others do, what's constantly done is to zero out na lang yung So, tilde, 0, plus. Okay, so what are we doing here? We're saying that make the intercept 0. So, hindi nalalabas yung intercept sa model natin. Okay, let's call this 3B. 3B, para ma-preserve natin yung 3A. All right? So let's run this. Run. All right. So what do we have now? Okay. Notice guys, wala na si wala na si intercept, no? The values did not change, no? 2.99 standard deviation pa rin to. Okay? Ito kasi naka-negative 1, naka-exponent na negative 1. Just to be consistent kasi may negative 16 to. So para mawala na yung intercept na yan, anyway 0 yan. Okay, we regress, ginawa nating 0, no? Tilde 0 to indicate that the intercept should be 0. And then we have these figures. So again, ang ibig sabihin nito, for every 1 standard deviation increase in your NOx, there's a corresponding 0.2995 standard deviations decrease in price, ceteris paribus. And we can see here that these are your beta, ang tawag natin dito, beta coefficients. These are standardized values. We use the scale function in R in order to convert our variables into normalized or standardized values. Okay? Okay, let me pause for a few seconds kasi magta-time na rin. Any questions, guys? Any questions? Paki-chat naman kung clear guys. Clear ba? Okay, good. Good. Also guys, what do you notice about the t-value? Nagbago ba yung t-values? negative 6.26276, negative 6.276, p-value is practically 0. The t-values just do not change. No? So whether we use unstandardized variables, unstandardized figures, or standardized figures, okay, the p-value will not change. The t-value does not change. Pare-pareho lang sila. And here we can conclude that rooms has the highest impact on the price. Why? Because these are now comparable in terms of the magnitude of the impact. Kasi pare-pareho na siyang expressed in terms of standard deviations. Okay? All right. It's already time, guys. Thank you so much for coming. We will, of course, hopefully, tulungan niyo lang akong pag-pray na hindi na magkaroon ng issue yung computer. I'll stop recording now.